Hello everyone, I'm late and I have an excuse today. A German Autobahn is my excuse. Welcome everyone to the stream. So, before I dox myself, where am I? Here. So the problem today, or the problem, I don't start with problem. Let's say we have challenges, no problems. I worked until 5:30 today and thought, oh well, I will do something nice for myself and go to the lake. And because we have like 30 degrees C here today, or we had at least, and it's one of the last warm days of the year probably. So I thought, oh yeah, I go to the beach and I hopped in the car, I drove in the direction, and as soon as I got on the Autobahn, there was a traffic jam I was stuck for 1.5 hours in the traffic jam. There was a burning truck, so there was no movement at all for 1.5 hours. And then I just had to turn around, next possible way, turn around and go home. So no rest for me apparently, just stressful traffic jams. F me. Hello Dutch, hello Jumbo, hello Deshipu. No rest for the wicked, yeah. Yeah. All right. Okay, so apparently before we start doing the sonar scanner, I have a different project that I need to figure out. So there is an issue with, let me switch, no, I don't have the HDMI connected yet, but I will in a second. So I can share my debugging setup with you, and then we will figure out what's happening there. All right. That's not it. GH1. And bugging. Yeah. Yeah, so that's my switching matrix. Should I remove that? Yeah, I will remove that. You are not late. You are not late today. Wagon loads. Hello. So you remember those things? I don't know if I showed. I didn't find the live stream. I didn't find any footage that all is lost. Yeah. Here we go. Let me remove. Oh, I unplugged it here. You know what? I bought fondue. So we could have fondue, but this is way too warm to have fondue today. All right, so, yeah, that's way too bright. Are you using pill bottles for electronic cases? No, I'm not actually. Yeah, yeah, I don't have like small thingies that I have always like reels or whatever. Yeah, so that's like the magnetic. That's like a RGB matrix with magnet connectors, so you can like assemble a bigger matrix. And what I'm doing is I'm trying to implement a really high switching rate for that. That's not what I wanted to share. I will probably dox myself. God damn it. Where is it? Here. I come unprepared, so please don't judge me. Okay, so what's happening here is basically we have frame, that's the frame buffer, RGB, so we have 3 colors components with the Pongo. I don't know, currently it doesn't work properly. So we have XRes, YRes. Oh wait, that's wrong way around. We use YRes here and XRes here, but it doesn't matter because both are the same. And we can set a pixel like that, but then we have we can convert it to a switch. I need to explain that in a way with paint. Okay, let me fill that with black and draw with white, like this hacksaw of YouTube that you watch. So what I'm doing is I have parallel addressing for the rows. Oh, what? Why doesn't it draw? Do I really need to select the color here? Okay, yeah. So I have parallel addresses for the row, like that, and I have parallel addresses for the column. So I have high side and low side drivers for this matrix. So I power this up, and then, oh wait a second. No, yeah, I power this up, and then I set the individual pixels. They're only on off. So for achieving like RGB values that are not only 1 and 0, we need to do something like PWM. So we would need like to have something for each pixel, have something like that. And then for the next row, yeah, better chips. Yeah, but it's too small. It's only 8 by 8, so. What I'm doing right now is I have like the 8, let me remove that. I have the 8-bit value. Let's say this is is it enough? I don't know. This is lowest significant bit, and this is 1, 2, 1, 2, 3, 4, 5, 6. Oh, it's actually 7. Wow, 7, and this is the highest significant bit. So what I do is basically I converted. So I light up in the first iteration. I light up the lowest significant bit for a really short time, like beep 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 beep. Then I do this for all the matrix, and then I continue with the next bit and do it twice as wide, and so on and so on. So I mean, and this happens. So lowest significant bit for all the rows, all the pixels, then higher and higher. How many pixels I can have up to? I can time up to 13 bits. 13 bits is still like starts to flicker. So continuous. Is it call row addressing or one continuous series string? No, it's call row addressing. So here, these are basically, these are like 24 because we have 3 colors, and these are 8. So these are actual pins. So and we have drivers in between. So here are like drivers, boop boop boop, boop boop boop, because we have like we need constant current, and if you have like one row here, that needs like this one pin needs to light up 24 LEDs at the worst case. So there would be not enough current. So we have drivers on both sides, low side and high side. Oh well, okay, here we go. Now, what? Yeah, so higher significant bits, and this gets like the stuff gets longer and longer. And what I'm doing right now, setting, like I convert basically the frame buffer, which is defined in XY, like, oh, that's Y, that's X, and you have like 24 bits per pixel, 24 bits or 3 bytes per pixel. What I do is, or not 24 bits, that's like color component. Let's say we have like 8 bits. In that case, it's 8 bits. So let me remove, no, that's whatever. It's only, let's say it's only 8 bits, okay? So what I do is I convert that array here to bit, color bit, like a plane, and Y. So I can simply take just each whoops. I can basically take for bit, lowest significant bit, I can just parse through. Oh, I should sort them different way around. Would be more efficient. So I take the for lowest significant bit, I just take these 24, this 24, this 24, this 24, this 24, this 24. Three bit to output row selector to gate which row the column data goes into. No, it's actually, it's really 8 bits. So, so basically I just convert the easy to access RGB array to a format that's better for basically taking, like, sorted by bit, so lowest to highest significant bit, and Y. So I can take the values, I will show you the resulting okay, this is the one that's not optimized, it's easier to read. So what we have then, I have a 32-bit which contains that the first 24 bits are basically the all the RGB, no. Yeah, all the pixels of the matrix. So here, 24. These are basically in this ports. And then we have like the bit, which is basically which bit it is of the color, like fidelity, and then Y. And Y increases. I set one row at a time with 2 port writes. No, only one row per. That's too complicated to arrange, to have that. There's only one row lit at the time, but I'm switching like all the time, and then it gets slower and more persistence. Hello, Dreads. Or Dreeds. So, and then it gets slower for the highest significant bits and so on. So basically it's like binary search reversed, more or less, for the right color. And at the end we have like a sum of the intervals which are for the lowest significant bit really short, and the high significant bit the largest, always like twice as long. So we only need like take that 32-bit and write them to the 2 ports that I'm using. So we have, where is it defined? You can see it here. Yeah, R is basically B8 to B15, G is B0 to B7, and B is C0 to C8, and the row selector is basically C8 to C15. That's quite convenient on this processor. It's the CH32V208, which has, I think, the most pins for the 2 series. Yeah. So that's easy to set. And then I also set basically the min ticks per subframe shifted by the bit. So that basically takes longer and longer the higher significant bit it is. And this is the minimum ticks that I need to perform like this whole interrupt. Otherwise it falls apart. So I determined it to be 40 ticks. And that's not cycles, so I counted it's only 16 megaticks per second. So we have like we can what is it, 400 kilohertz update rate on the screen if we are using it only with 1 bit. For if more frames, then it takes way longer. It starts flickering at 14 bits significantly. 13-bit is acceptable color depth, which is really cool already. 12-bit is safe side. But I have one issue that we need to debug, and I will show the issue right now. So what I did right now is I have a test sketch with 12 bits, and I'm setting all the pixels, like all the colors R, G and B to 1. So I wanted to record for my video for comparison, what is the lowest brightness that I can achieve with this high color depth. And then you have a good comparison why 8-bit is way worse than 12-bit. But I have an issue. I will show that, I will switch, let me disconnect this one and this one. I will show you what we have here as a result. So this one runs already the code. I hope I plug this the right way around. No, I believe it's the wrong way around. But it really doesn't matter, at least. Nope. Oh wait, it's not plugged in. So I need to, yeah, and now it's reversed. Hey TMK! Alright, here you can see. As you can see, you can't see anything. Now, here we go. So, I got a Houston, we have a problem. So, what you can see here is it's very dim for 12. That's we want it very dim. But this row, it's all right, and then it gets dimmer, until this row, and then last row is bright again. Something is off with the timing, and I can't find the problem in my code. So if I reverse, let me reverse basically the Y. I will set it to 40. I don't know, 64 ticks. So we have no. Yeah. Let me program that. Okay. Now it's flickering. Why is it so flickering? Because of ISO. Okay, let me change the ISO. Yeah. Okay. So still, this row bright, this row not so bright. So, and now I will flip the rows like upside down the matrix, so we can see it's not the hardware, it's the software, and then we need to find out why. So I have 7 minus. You can see that, but that's just a minor change to test it. And here you go. So can you see the difference? Okay, here there is no more like only slight difference, and it gets dimmer. Last row is bright again. So you can certainly see a difference, and it has to do with the code. And I need to find what's wrong with the timing. And it doesn't help if I brightness a PWM issue. Yeah, that's what I think. Hey Christian. I tried several things already. Sorry! Oh. Yikes. I need tissues. Traffic jam, yeah, obviously. So it's not? All right. Let's check. Make it bigger so you can see that it's still flickering. So what I tried is to increase basically the ticks per frame. It doesn't help. If we do like okay, let's program it. Okay, now it's too slow. Shit. We see serious flickering. actually, let me change the depth so it's flickering less than now. Here we go. It seems it's less apparent with the higher I go. Now it's sundered. Now you can start to see it. Like this is way brighter than this one here. But it doesn't, it seems not to be like the issue that our timer is too slow for the update rate. Maybe, maybe there is an issue with the priorities of the timers. I can try to set a higher priority. But what is the But it doesn't make sense that like anything that happens outside. Yeah, that's camera FPS. But you can see like we have the issue is basically between. Oh well, let me zoom in. Ah. Let me do it for you. Ah. Here. Why is it so odd? The brightness difference between those two. The upper one is dimmer. The upper one is dimmer than the lower one. Yeah, that's the issue, and I don't know why. Where is the problem in my code? Restart counting. Okay, so this is my optimized code. Wait. Paper on top. Nah, that won't help. Really. And increased rate might help, but they are already diffused from like they have like the material. So if I increase that, let's say again to 64, which is almost twice as fast switching speed, it's more apparent. Yes, but that should be like less regular. So this is like happening, it's going dimmer and dimmer and dimmer, and then it's good again. And this is what I want to measure or check with those oscilloscopes. So we can remove that. A pulse width. It's a pulse width. We just changed the time. So the compare time, what we can also do, let me do that, restart counting. So we don't need to restart it on ourself. Restart counting. Where is it? Here, count. because I thought, okay, let's do it like that manually, that we restart the counter once we set the values and then clear basically the interrupt flag. And now it's even more apparent. So there is a discrepancy between like when we arrive, update these values. But it has to do. Okay, last row has some extra code. But shouldn't that be like irrelevant if the counter already runs in the background? Does it actually change? Let me check. No. It doesn't change. It's even worse, huh? Right. So that doesn't do anything. Is it worse? No. It's the same. Similar code to the other rows. Oh, you mean like resetting that everything. But okay, we can do that. We can do this. So the increment happens here. Port. And the compare is set here, the compare value. Okay, let's see if, but this is like really strange. Oh, now everything is broken. Yeah. Everything is broken now. What did I do? How do I reset the view? How do I reset that? Previous set color. I don't know how to reset the view. Preview scaling, scale to window. No. Reset transform. Ah, here we go. So why oh yeah. Yeah, right. I should. Nice. Yeah. Still the same issue. Last row is bright, the others are not. Milliampere. Hey, C Dice Age. It has a driver, so that really shouldn't matter, because I have a high side and low side driver on between them. I can show you the schematics if you're interested. Here we go. So this is basically our B and G. Oops, sorry. And this is the row selector. So these are low side drivers, and this is the high side driver. So that should be fine. And there is even, okay, it's a 10 microfarad capacitor. I don't know if that could be the issue. No, it couldn't. Why should it matter? Like, I think it's something to do with the switching, and we can use the oscilloscope to determine what's happening there. But I was testing it already, and I couldn't see what's going on. Here, to be the same. No, that wasn't the issue. That won't help. It will be optimized away anyways by GCC. Obviously, last row takes the longest because it resets this counter, and also it resets the address here. What we can do is we can rewrite it to not use anything at all. I had a version that let's rewrite it. Okay, so this will be basically, whoops. Do I have, huh? Why the I have an English keyboard set here. Okay. What I can do is, it won't be the most optimal way to do it, but we can do a static, oops, static I, and then we have basically, no, int y, int bit, and we do y first, so I and 7, and bit is I, shift 3, and what do we have? Bit count -1? No. Color count, color max. Is this the right? Yeah. That should be basically here. Because that's then, it's counting. Oh no! Color, no. And color bits -1, okay? That's, does that work even? No. Shit. That doesn't work. With that only works with 8. Yeah, we can test it with 8 first. Otherwise that won't work. We would need like an if there. Unfortunately. Odd frame. No, we need to, no, we actually need to, do it here. if I equals, so we don't need that. What? Color bits shift 3. It turns off. Hmm. Hmm. Ports. And then ports. Huh? What's the issue? What? Oh, wait. Just compiling this. Huh? What is it complaining about? Oh, wait. We don't need static here. Okay. That doesn't work. It doesn't work. Yeah. Y and I color bits oh yeah, there is an issue here. I wanted to no, Y and then color bits. That's correct. I'm not incrementing I, you're right. That's why I need you to figure everything out. Okay, here we go. Still, same issue. It looks like I don't know what it looks like. Maybe there is a delay on the bus or whatever. It's so strange. It could be just for the first bit because that's really tight. And for the next row we increase the clock cycles. That's why it has time to breathe. Maybe it's really like the priority whatever. But if we slow it down, okay, it's a little bit better. Let's say 100, whatever. It's less apparent. Now at 100 we can already see it. 120. I want fast clock rate. I don't want slow clock rate. It's also 120. Shit. 128. Trash. H. How about we reset it that and line up the interrupt already in the first yeah, we also change the compare already here. Still, last row is brighter. Okay, let's scope it. I will do color bits 10, so it's we can see it's more apparent. We could even use color bit 12, even though it flickers on the screen. Oh wow, that's really dim. Dim and flickery. Okay, let's do 10. Should be still apparent. Yeah, there is certainly a difference in brightnesses between you can see, but I can. Let me switch to that. You have the switching frequency. Okay, so I will turn on the scope. Our scope is turned on already. Blink, you know. Oh, wait a second. So, what do you want to see first? This will be like one of the RGBs here. Here we go. We can measure, add measure, and I can open, open that, okay. So what do we measure? Not frequency, pulse width, time measurement, not period, not frequency, width, positive width, okay. There is no other, okay. How do we measure that? Oh shit. We need to compare them. They're on for such a short time. Seven microseconds. Let's measure this one. Actually, no. Seven, 1, 5. This is terrible. Let me lower the bits to 4 bits, and then let's see if we can see a difference there. We can change the trigger to to find the shortest signal there. Hey Ray. Okay, let's find the shortest one. Eh? Oh, wait. No. Okay. 7.1. That's all the same width. But I'm not sure if... Shoot. Oh, yeah, we can do period time. Hey. No, that's the trigger. Measurements, add measure. And we want also the periods. Is it 80? I'm feeling a little bit hungry. 7.1 times 16 is 113. And we have 105. Oh no, wait. Huh? Why 16? Why did I say 16? It's 8 rows. No, wait. Oh, it's 16 values. Hey, Brian, thank you for the sub. 5 months. Nice. Thank you. Yes. Yes, you're the best. I can celebrate with a cake now. I will bring some cake. I don't know. You must ask Tony. She made it. It has a like chocolate cover, but inside it's probably some sort of chocolate chip cake or whatever. Stracciatella cake. Oops. Okay. The signal width. So, secret that doesn't work out. Oh really? Like bitumen or whatever. Hot air station. That was a lot of work. Let me run it at 10 bits and then measure again. Period is 7.2. That would work out. So that works out 1024. No, that doesn't work out. $1,024 times 7.1. Oh, no, that works out. It's 7,270 and we have... Oh no, we have some microseconds over. So the timing is a little bit off, but I don't know if you can measure that so precisely here. Like what would be the precision at this scale? No, that actually looks like 7.1. We can take a second probe and measure the overlap between but I have no clue. That's not a scanner project. I'm distracted with ADHD mode now. I need to finish that project, and I was really confused because we get mixed results. It behaves really strangely, especially on the last row. Let me show that you missed that part. So my issue is that this row is brighter than this row. This gets dimmer and dimmer and dimmer and dimmer and dimmer, and this one is bright again. I have no clue why. Yeah, row behaves a little bit lonely. Do you can the 5 voltage? Huh? It looks like it's only 3.3 volts. Oh no, wait. 5. You mean like yeah, we can measure that. Oh, yeah. Okay. That might be we can do it. Can we do it while while the matrix is on there? That's the issue. Okay, let me check if I can access everything while the matrix is on. But why would be the last row? Or is it the first row? No. Less lit than the other ones. Shit. I don't know if this is the ground or... No, this is ground. This is very dangerous. I can short things here now. I don't want to release the magic smoke because I need that. Nah, doesn't do anything. The 5 volts rail is perfectly fine. Ah, shit. We can check the outputs here. Maybe the slew rate is too slow for the... No. Okay, let's make it else. Risk V instruction set is so strange, it probably doesn't matter. There is like one opcode that skips a complete... yeah, no change. It's not that apparent for the eyes, actually. If you look at that... It doesn't look so different. Oh yeah, because we increased the time also. It's 128. If we do 40, I don't know if that falls apart then. I don't know if 40 will still work. Might not work anymore. Yeah, that doesn't work anymore. 64. Let's do 64. No. Hey, Death Shaker. What we can do, let me try something. I don't know what happens if I do that. I just do 2 by 2. Huh? Yeah, it's totally broken now. Nice. Yeah, this is too bright here. Oh wait, that's shutter. Oh yeah. I need to remove all the instances of stupid conversion. Yeah, magic numbers. Here. But that shouldn't cause that big of an issue. Sorry. That's my nose hair. Hello, Sonic. You might help. That's not the sonar scanner. I'm sorry. Rip ears. Oh no. Sorry about that. Also sorry to the people who are trying to fall asleep right now. Oh yeah, that's why. And okay. This is magic number hard coded. Nope. Yeah, but it doesn't work. Fuck this. Sorry for my... Seventh row. Yeah, we can do 7 Y-res, yeah. Wait, no, I inverted it and we get the same result. Like it has to do with the timing, with the interrupt timing. I don't know what actually happens, why it slows down at some point. But if we invert like 7 minus, you will see the it will basically, the brightness will invert, and this is now the brightest and this is less bright. So it has really something to do with the timings, but I can't see it on the scope actually. I don't know why. What's happening there that this happens. Let's try setting everything to 2. So let's check this, like if it's only happening to the... Yeah, that looks identical. It's only at the fastest switching speed. Now I need to know. Okay, we can check. What I want to know is it could be possible that we just hit the slew rate of the driver, and basically the voltage drops and drops and drops with every switch that we get at this high speed. But what I want to know is why the last row is brighter. Yeah. Also, like I need, when I set the comparator, the compare value, I need to set it to the current bit depth. And then that's what's happening. What I'm worried about is that if we like shift it or something, like the comparator time is, but we don't increase it here. So basically, if I is 0, wait, bit. So we don't shift. We have for the whole first timing, and then bit only gets increased when y-res increases. We can try to check the slew rate, actually. Okay, let's test that. I will try. Let's do and 3. Okay, let's try doing that. Don't know if that happens. Oh, dies. I've broken it. It sometimes. Oh wait, Shift 2. Let's try again. Oh, that looks quite bright to me. Nothing happens there. Wait, is this one saved? Is this the lowest significant bit? Because that looks way too bright for the lowest significant bit. Oh! I have an idea. We can do the following. Let's revert these changes here. No, that was Y. It's okay. And let's not set all the pixels to 1. Only. Wait. Like 2 pixels, okay? Still. Still the same issue. If I only set 2 pixels. So slew rate is not likely to be the cause here. I have one thing that I want to try. That's here. Set priority. Preemption priority. So what is the highest priority then? Oh, you think that could be it? I mean, it's 64 right now. No, that's the number of ticks before the interrupt. So every interrupt it takes like 64 ticks, and then interrupt is triggered. The interrupt can have a delay. I might. But that's only the compare value. I change only the compare value, so I rely on the compare value to be set as fast as possible, which is all right here. I don't know what's there is no documentation. Priority, preemption priority, sub-priority. What does that mean? I'll try to find out. Okay. Let's do 0. Nope, no change. Still same issue. doesn't change anything. Priority timer. Timer priority. Tick IRQ. Hey Tuna. Yeah, I could do that. Actually, I could do that, yeah. I can do an offset because it seems that it's only in the low range area. But why does it happen? I want to know. Why is it like we need the explanation why the last row. Is it the last row? Yeah, it is the last row. Why is the last row brighter than the other ones? It takes longer for stuff to, but it can't be that much longer. So we draw one, that takes time. We draw second, it's less and less time, and the last one takes like really long and starts over again. What is so different in the last one? What we can do, I have an idea what we can do. This is my optimized one. How many devices made the LCD matrix? What? Yeah, it's a little bit difficult. I can test it with this code here, because here I have an exact comparison. So let's try doing that. Oh. Here we go. Yeah. It always happens there. Okay, I have an idea. We can make this all. This is like not constant speed, okay? So we can have something like that. Const int next bit. Oh no, there is the port frame. Shit. Okay, okay. This is crazy. How many bits? We have 10. Wait, okay, so that's 4, 5. The problem is we need to do this as well. Or we skip that optimization for now. Okay, let me clone that. We do this. This is should be bit less optimized, but and this should be Y. And we don't need. Yeah, that's all right. This is less optimal than anything. Okay, let's do it. Long P. Oops. Bit, and then the thing that happens here is basically oh shit. Oh no. No, that doesn't work like that. What we can do is just an array that points to the beginning or whatever. Yeah. I need to do this. This is not performant at all, but it's just a test. Oops. think a mosquito got me. Yeah, that's basically what's happening. Else, so it should increment, and then for wait, no. Oh. Huh? Color bits. Color bits, okay. If basically the same here. Yeah, the last one I will handle here. Okay, offset bit and offset Y. So here. Oh no. Yeah, we need to count this differently. We need to do it like that. Uh, Group 1, what does that mean? Okay, I think this might be right. Huge experiment. Doesn't work. Wait. It compiled. 0 errors. I don't see anything here. Maybe it's too slow now for... No. B... Y... Why not worky? They said priority 1. And then priority group 1. Okay. Yeah, but I still don't see. Let's a sanity check. Huh? Maybe I overwrote. Oh. Oh yeah. I need to fix that again. So init offsets either overwrites everything yres color bits b and yres why does it it's just initializing offsets before it Huh? What where does it fail? Can anyone see the issue here? Bits. Okay, let me do the return. Doesn't help. Huh? I don't get it. Okay. What do I do wrong here? Color bits. Complain about memory or something, maybe. No. Data is no. I'm trying. No, it's not a super mega cluster, it's the magnet matrix. Yeah, but I don't even use that, so it seems like either I overwrite the frame or whatever, but what is the issue? Am I out of bounds somewhere? Init offsets stays like B stays within the bounds of color bits and Y stays in the bounds of yres. I just initialized that. Huh? Oh, this is strange now. Yres offset Y. Huh? Brother, huh? Nee, that's the wrong meme. Brother, that's the right meme. Okay, let me. No. does it die? Now it does nothing. Okay, we end this row. We just need to identify the row where it happens. It's not this row. Stupid. I should give up coding. ASMR. That's not ARGB. It's like 24:8 matrix. Because it has like the R and G and B LEDs inside. But I'm wondering what is going on here. Yeah, that's the offset to the next value of but I'm not. So what's happening here? I'm not even using these arrays right now. So the init offsets happens here, but I'm using this one here. It doesn't even use the init the offsets. Something's really off. I can debug it. Oh wait, I can debug it. Let's see if I override in some way override my stuff here. So let's put it here and run it. All right. It never arrives at that breakpoint. What? Wait. If it never arrives here, yeah, but why would it like stop working at all if there is no code? Let me check that. Let's run it. Oh yeah, we can debug the variables, it seems. Can we? Can we add one? It would be strange. Oh wait, that's convert frame. That's the wrong code. Here. Boop. Oh, here we go. Huh? Oh, what? Optimized out. It optimized out. B is gone. Huh? So it never stops or what? What sick optimization is that? That's broken. Huh? But it worked. Wait, but it worked. And now it doesn't work anymore. It doesn't show anything here. Static, volatile. That's really strange. Might have overwritten. Let me do convert frame again after this. But why didn't it want to break here beforehand? Oh. Let me stop hammer time. Ah, fuck. How do I B variable, but why? Why should it, like, it would be wrong either way. Okay, let's debug it. There's the debug. Debug it already. Never arrives. It's 10. Const int 10. That's like a constant. There is no... Yeah, it's strange. Oh, well, I can do that. Yeah, I'm using them now. So let's try again with debug and see if it's still optimized the way. Okay, B0. Okay, and now can I... Oh, it actually shows me the contents. That's what I wanted to see. 1, 1, 1, 1, 1, 1, 1, 1, 1, minus 9. This is what I expect, okay? Yes. And now let's continue with that one here. Oh. Okay, let's start over again. Huh? Okay. Yeah. That's what I expect. I don't know if I can break in the interrupt. Alright. Never happens. Hmm. Why do I set it here? Yeah, we can clear it here already. Bit and Y. Hmm. Initial value of bit is 0. Also Y is 0. So why doesn't it work? No worries. Let me... Maybe this thing is wrong. No, port frame. It's color bits and virus. It's also right. Could still frame X. Oh wait, this will be color max. Wondering if I overwrite. No. Nothing's happening there. Ah. Huh? No, nothing works anymore. Oh. Oh yeah, that's not predefined. Okay. Huh? Something's really off now. What, do I still have the timings? Maybe now that's optimized, let's increase that significantly. Alright. So that might have been the issue. It's not very fast this way, huh? This is the old one. Okay. Gotcha. Stops working. What? It can't be. It can't have to do with the timings or whatever. No. Wait. Yeah. This is the issue. I should initialize everything beforehand, before I start the timer actually. Set enable IRQ. Yeah, that's the issue. The first time the IRQ is called, it's like either random. Yeah, here we go. It's enabled here already. So I should also change this direction. Oh, it's all my fault. No. That's the interrupt, yeah. Okay. So we don't need that. We don't need that. And now we can start testing, huh? All right, okay. Now let's start testing with our offset stuff here. Oops. Yeah. Oh, yeah. Oh, wait, it works. What? Okay. Nah, I think it's still the same. Look at that. I should stop the obsession with this brightness in the lowest significant bit. There is no difference in code anymore. Look at that. There is still brightness difference, but the code is linear. There is no more stuff happening. And that's even like with 128. If I go down to 64, let's see if that still runs. Yeah, that's even more apparent. Does it still run at 40? Yeah, it runs at 40, but it's really... Does it run at 38? Might be faster, the code. It seems to be. 36. No. I can't tell. It's breaking up. This needs to be determined with the oscilloscope. What is the, if it's faster than the other one. I will measure that now. So let's take off the matrix and see what's the lowest clock as we can do with that. Yes. Yes, I'm sure. I'm sure. Oops, oh wait, trigger. OCD mode, yeah. Oh yeah, or I leave it because. Oh yeah, we should do that. Yeah, I want project properties. I want to be fast. Yeah. Or is what is optimize fast? Peeps, I want fast code, not small code. Sized, more, most, debug, fast. Is it just like a fast optimization, or I want fast code, not small code. Okay, so we are currently at, what is it, 5 microseconds per division, and I go to 40. Okay, 40 is shorter. So this is our benchmark now. 2.6 microseconds. If I do 39, it's still there. 38. It might be faster than the other code. 36. It's still there. 35. At some point it should start breaking apart. 34. 33. That can't be. 32. That's really fast. But it doesn't change in size. It's like 2.5, 31. 5.8, 258. Doesn't change anything. Yeah. 5.8 doesn't change anything. Probably because no. Let me do 28. I don't see a difference in timing here. Huh? It's like nothing is happening. No, between pulses doesn't work in that case because we have like all the 9 other bits that are very, very long. The pulse width it falls apart if it's too fast usually, but or you know what, we go, oh, that might be also a thing. We just increase until it starts actually increasing. So that might be also a way to test it. Oh, 2.8. 40 is 2.6. Okay, 44. 2.58. 45. I think I have faster code. I don't know. Still 5.8. 46. Maybe that's the difference. Like we thought we are doing it right, but never did it right actually. Oh, 6.4. Okay, so it's 46. 46 is the lowest that we can go, it seems. Okay. Yeah. With this code. Okay, let's check the other code. If it's faster. It won't be faster in the last row or anything. But there is the discoloration anyways. Okay, so let me zoom in. 5.8 is the benchmark. Now I will switch to the other method, to my ominous faster method. Let's see if we can make it, if it runs the same speed. 5.8. Yeah, that's 46. That's very like consistent speed. Now let's try 40. Yeah, that's faster. Let's check if 41. Yeah, that's actually slower. 39, you will see it start falling apart. Oh, 22, was it? 22, 18, no, 38, 22, oh, did it make a faster code for me? 12. We are at 36. Oh, and now it crashed. We are back to 30. 37 is the fastest that we can go with that code. Alright, that's only 2 microseconds. 2.12 microseconds. That's quite fast. It won't be nice, but it's fast, faster. Let's take a look. Yeah, oh shit. Look the brightness differences here. That's quite substantial. We can try the other one again and see which one looks better. Well, that's like 15% faster, but it looks shitty. It's not consistent. The other one takes some memory though. Here we go. No, it's the same. It's the same. Dudes and dudesks. It's the same. Doesn't do anything. Doesn't do shit here. Here we go. Let's do it. Boom. This is the fastest update rate that we can have. That's 10-bit. We go 12-bit color depth. Here we go. Yeah, that's like really dim. Actually 13 bits looks also nice. No, not much flicker here. Let's try 14 bits with our new fastest update rate. Yeah, that will flicker. Oh wow. Actually I can't. Okay, let's turn it on. Let's turn the total brightness, because only with the total brightness you will see the flicker coming back. Like highest significant bit will be the flicker. Here you go. Oh no, you don't see any flicker. Why not? Oh, update rate is at 60 here. It's in sync with the shutter somehow, so it doesn't. That's so strange. What? This is strange. Okay. I see it's certainly flickering here. Oh. Yeah. You will. Let's do it like this. Max color. No, what is this? Yeah, I know. Color bits -1. Okay, so let's turn on the highest significant bit. And then the flicker will be apparent. Oh wow. Oof. Yikes. You can see that. I will increase the shutter speed. Interesting. What kind of frame rate is that? Oh, it seems to be. It can't be. It might be 25 or something, because I see seizure warning. Yeah, it seems to be like around. It might be 12 or 25. So. Yeah. Okay, so let's do 13-bit. Either I'm old or I don't see any flicker anymore. So what is this? 25 frames per second in 13-bit? Okay, with the shutter at what is the shutter right now? That's at 100. So I will put this is now 100 frames per second, it seems. There is no. Yeah, Is it 50 or 100? It seems like it. No, it's 50. I think it's 50 frames. We can calculate that. So we get 16 megaticks. And we have 37 update rate. So we have 12 bits. Yeah, that's 37 times 12-bit is 4096 150,016. Yeah, that's 100 frames per second. That's over 100 frames per second right now. 16 million. We can measure that. We can measure that with the scope. So this is now 10-bit display with fast update here. Frequency is 120. 100. Yeah, that's cool. Okay, I need to record that for my video. So this is is this the frame rate? Let me check. Yes, that's the frame rate. Okay, we have 120. No! This is at 10-bit. No, 12-bit. What? No way. Okay, that's at 12-bit. We have 120 hertz. That's faster than the Evo OLED whatever. Doesn't do 12-bit. It does only 10-bit. So let's see what we can do at 10-bit, like the fastest OLEDs. 480 frames. And what's... Oh, really? Does it display 12-bit also? Okay, at 8-bit we can do 1.9 kilo frames per second. This is ridiculous. Nice. All right. Doom when? No. Now the interesting part, my dudes. The interesting part will be, let me do something here. Okay, doesn't work. I've already started to... I don't know if we can do the frame rate from Flash. This is from SRAM. Flash might take longer to read. Okay? So disclaimer, if we do the Rickroll, oh yeah, let's try 11 bits then. Yeah, no, we get 240 Hertz with 11 bits. Okay, let me check what we got with 14 bits. What was that? Yeah, that's 30 Hertz. But it really flickers. It really flickers. 30 Hertz. That's strange. That looks like CRT. So 14 bits at 30 Hertz looks like CRT. It already looks at 60 Hertz, it looks like CRT. Okay, let me check that. Here. Oh yeah, no. Rolling shutter. All right. Ah! Let me do it for you. Nice. Okay, so we figured everything out. I think what we need to know for that one. So I don't need the oscilloscope anymore. I just skip my OCD, remove the scope, and continue. Whew. That was exhausting, and it's warm in here. Wow, that's flickery. You get the full rolling shutter experience at 14-bit. Let's do 8-bit then. Oh wait, here we go. 8-bit experience. 8-bit experience, and all right. Oh. Nope. Oh, I can do shutter like this. Is you can still can see the rolling shutter at shutter speed of 2000 right now. 1.6. Oh, now you can see the rolling shutter at the individual LEDs. This is so strange. Oh, that's a cool effect. Shutter of 8000. That's 4000. 225, 2000. Yeah. 1.6. That's strange. Like wee grid. Nice. All right. So I go back to black, no, to 400, and I close the iris here. I close the tesseract. here. Woo! Morée? Yeah. Looks like. So, I found 8x8 rickroll, and I asked ChatGPT to make a converter for that. Let me modify that. Wait, that's not it. Do I have it here? Fast frame. Yeah, I have code here. Fast frame. Oh no, is there the HTML? Oh no. Shit, it's not here. Fast frame, let me check. Code, yeah, there is Rick 2. So I will image container, max site position, zoom, let's say 8. Okay. Somehow I have like, okay, let's take, I think I can load something like 400 or 500 images and fit them into the flash of the device. Okay, so let's load that. Start slideshow. Oh yeah, I need to increase this playback speed to, what is it? 60 frames per second would be how many milliseconds per frame? $16 then, okay. 16 milliseconds, okay. So, oh yeah, and let's zoom even more. What's the pixelated thing in, anyone knows what the pixelated filter is? Flood, fill, opacity, flex, direct, scale filter. I just don't want this scale. We just need to scale it up. Do like per 16 pixels, per 64 pixels. We just need to put an individual microcontroller that does all that stuff. That's very simple. Just scale it up. Just multiply it by 11. No. Start slideshow. Oh, this is like a 30. I think that might be only a 30. But you can recognize it, can you? Ah, fuck. What is the CSS filtering? Image rendering. Oh yeah. Image rendering and then pixelated. Okay. This is the one that we want. This will be even more recognizable. Yeah, let's do that. This is too damn fast. And I told it to make an export as array, but this array exporter is terrible. And I need to convert it to my... I will convert it to this 32-bit these 32-bit values already. I think that might be more advisable. Just to arrange it so I can just take it and put it on my registers there. Never gonna give you up. Boop 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 boop. Boop beep bop. Boop beep bop. Hey Konrad, thank you very much. Didn't notice you. Here we go. That's what did I want to do? I wanted bigger. Zoom 32. The zoom is like really cursed because if you like try to work on that thing, it might bite you. Yeah, and I will also change the speeds. 33. Here we go. Rickroll. Now we are talking. Obsession time is over, like OCD, and we will just do. We can even do gamma conversion because LEDs, and we have with like a 10-bit, we can actually get a nice smooth gamma curve. This is now, oh yes, here we go. Graphics mode. Yeah, graphics mode activated. All right, so. Hey, Sienna. Lurking. HDR10, yeah. Rick Astley must be getting very rich of all these memes. Yeah, he will sue me. You know what happened? We were reviewing Kaspar's channel last time, and there was actually a content ID claim on the whole stream. I just like for one song, for 1 minute or something, there was a claim, and I didn't bother like to object or anything, and I just let it remove the part of the stream. So there is like 1 minute missing from the last stream because it was claimed by some Russian. It was artist. I don't know. We can check. But anyways, it was unfortunate. But I thought that was all were covers. But apparently it seems like one cover was that good that it was recognized as the original or something. Or meanwhile, like the artist that covered it claimed it for itself. Interesting. You can see, like in the reflections, something happening here. What is it reflecting now? All right. Let's generate the string. Let's generate a string. Yikes, that's big. Okay, download CPP arrays. Pixel data for each image. No, I'm not. That's too big. Huh? Control minus. Here we go. Sorry. CPP code. Thanks. Image data. Image pixel data, push. Hey, Rote. Yeah, you're probably surprised that's not the right project, but we are experiencing 1.9K 8-bit frames per second on this display right now. So eat disk LG. Eat disk LG. I forgot the frame rates that we are able to achieve. What was the 10-bit frame rate? 480? No. 240? 12-bit? No. That's not neopixels. That's actually an RGB array. Yeah, that's like there is no switching. Yeah, 12-bit was 120 hertz. Proper ones, yeah. We have parallel high side and low side drivers. No more Charlie plexing. So this is like in matrix mode, and that's the only possible with those modules here. So these are the modules. You probably know them. They are rare to come by, and I made this board long time ago, and it has a MEMS microphone actually, and it has a speaker, so we could play back Rick Astley there. Okay, it pushes some data, image name, data, canvas, and it pushes the complete data block. Ooh. Capture image pixels. When does it do that? Yeah. Unload. Play slideshow. Oh yeah. Okay, that's what I thought. So the problem right now is that it reads the elements. Wait. Play slideshow. It does only start button. Interval. Yeah, it only adds them image length. So we need to let it run for the whole duration for all images to be exported. And now we need to add like a proper converter here. So our desired code is, I'm almost lacking the concentration to continue, but I really want to make it run here. So fast frame, here we go. This is our structure that we want, and this is the convert frame. So we need this code. Yeah, focus mode. I think I need air, but I don't want to let the mosquitoes in. It's quite warm outside, so they are probably still active. maybe I can, yeah, I will try doing it like that. Wait. Function convert. Domi, mommy, Melania, Malenia. Okay. Hello. Convert frame. And we have oh yeah, for color bits, and we have only 8 color bits. So we have const. Oh wait. Const color bits. Let's export 8. So we have 8 planes. Let yres const yres equals 8. Whoops. One job. Wappa. Okay, here we go. Let's yeah. It's not far away. It's not. It's quite. It will be soon. Soon. Port frame. So how do we port the frame? Shit. We need. Okay, convert frames. Let's do all the frames at once. So for let frame equals 0 frames. Whoops. Frames length frame plus plus. So what do? We create the array of frames, the output array here. But bit, yeah. Out basically new array frames length. Okay, out. Then we have out frame equals, oh wait, that needs to happen here, equals new array, and then we have color bits. and then we have out. And then bit new array virus. All right. Or is it port frame? Yeah, out. Let's do this. Frame bit y, and then we have that. And now we need to do frames. We need to get the pixels from the frames. So what happens is oh, this is ridiculous. It made everything so complicated. I will rewrite this part. I will rewrite this part. I will keep CPP code here. And I will push only image data. I don't need everything else. Here we go. Image pixel data, but this is like capture. Will it export the same frames over and over again? Not sure if the load triggers only the first time. File reader, onload, image element, send, set interval. This is what happens then. Starter URL. Yeah. It seems. It's actually not that great. All right, we will just export and see what happens. So convert frames. So what we do is let convert frames image data, pixel image data here. And then we will debug that. And what we got, frames, basically, frames, frame, y times xres plus x times 4 bits. Okay, xres yres is defined. Okay, plus 0. Oops. All right, that should be the conversion of that. So let's test it. Here. Let's load just 4 files. Stop slideshow and then download. Oh no, it starts some stupid software. Yeah. Need to uninstall that. Oh, yeah. We didn't write anything. We wanted to debug it. Shoot. Alright, okay. So, sources. That's the wrong one. Page. Okay, here we go. Undefined. Oh, we don't return. Oops, wrong code. Out. Too much assembler. Wow. Here we go. Start again. Okay. Oh. It actually exports it every single time. But then it seems to do the job. We should drop an array into, like, just get the first frame or something. God damn it! How do I stop it? Stop it converting. Play slideshow. Play slideshow. Stop slideshow. Clear interval. Okay, here. So if current index equals images linked -1, then clear interval, else okay, this will do only one, and now we need to, okay, let's try it. Choose, take 3, start slideshow. Yeah, and now it's done, and it should have only 3. Yes, okay, 3 frames. Now we need to generate the exported code. Oof. How do we do this? Const long rig, or let's say animation, and we need, oh no, so let's do it like that. So const int frame count equals and then it will be conf length. Okay, here we go. Long animation, and then we will have frame count, and we have irs. No, wait. Color bits, and then irs equals, and then it starts. Everything starts. Yes, it starts. For let's f conf length f plus plus. I'm just old school. Pa 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 pa. F B. Hey Johnny, what? Thank you very much, super chat. Is this a super chat sound? No, there is only a TTS super chat sound. Thank you very much for the pink, with the pink shirt. Oh, peeps. Here. This pink for those who weren't there yesterday. Oh. Okay, let's do it here. This is pink. This is 405 nanometer wavelength. Here we go. What? What? What is going on? What? Wait. Ah, you can see it's too dark. It's not that bright. Wait. And I have my studio lights on. There we go. Let's try again. So, shall we build something with that? This nice glowy filament. It really glows. It really glows nicely. Look, I just. You got it! You got it! But I don't spoil too much. Shall we do this project next time, or do we continue with the sonar scanner that always fails? Because, I mean, behind me here, this one, we just need to put this in the AMS in the top and start doing. Chat controlled. Yeah, Johnny needs to. Johnny invited me already to his home, so I will go there and bring pink wallpaper, and I will drill one pipe, and then why is this not focus? Focus. Galvanometer, yeah, that's too expensive. The pink font isn't big enough, even though it increased. I'm thirsty. Okay. OCD, ADHD mode off. Let's continue. Shorter than color bits. Who knows? Who knows? The pink ribbon detect radiation. Yes. No, it's a glow in the dark filament. Bit, Y. Y equals 0, Y is shorter than Y res. Y plus plus. Okay, so we have CPP code plus that CPP code doesn't mind if there is a comma to Yeah, you're excited. You want to do it right now. We will do it next week, okay? Next week, pink LED stream. Yeah, I will change the video title. Wait, I can change it right now. Can I? You're distracting me. Let me work already. Pink ribbon. All right, so and now CPP code. Yeah, we will get Ricky. Just think you can work as a first device to store data on computer or memory drum device, but would like to store the data. Well, is oh, that's interesting. That's interesting. Like DRAM, you need to refresh it now and then. Oh shit, that's a good idea. Z80. Z80, that's a good idea. Like DRAM. You need to refresh it. Please remind me of that idea next time. We will do a great thing. This is more amazing than what I do all the time. Like this is all too sophisticated. I want simple ideas. If we just do not only a drum, we just do like a record or something. We don't even move it like in two directions, just rotate one strip or something. Huge rabbit hole. No, it just need to store something. It's a YouTube video. It doesn't need to be good. It just need to work. Work once for the camera, that's all. So, what do? We do conf. Somehow my eyes always hurt when I use those UV lasers. I don't know what is this about. B. Is this all? Is this what we want? I don't know if I missed something. I might have missed something. Yeah, phosphorus data storage unit. That's the. Yeah, but the UV ones are even more dangerous. They're really violent. That's why it's excited so badly. Okay. What does that say? Wait, 10. Do we have 100 frames? Yeah. It downloaded. It downloaded. My dudes. It downloaded. Image data. It downloaded. I don't know if it compiles. I don't know if it is Rickrow, if it compiles. Const unsigned long. Blah blah blah, Mr. Freeman. Oh, yeah, I should add some tabs maybe. That's 100 frames of Rickrow. Oh, there is one semicolon missing at the end. I will edit now. Okay. So I will take that code, new header file, rig h pragma. Let's just agree on just pragma once. Who the F uses those old defines? That's so old school. I don't know. I don't like that. I mean, every single compiler that's worth anything supports pragma once. Let's just keep that. Okay, rig. Oh wait, fast frame. Where do we add? Okay, let's add here include rig. No, that's bad. Okay, let's put it here in fast frame because we have all the defines in here. Okay, let's include rig and then do animation 0. Okay, so consts. Yeah. Okay, let's do that. 0, 0. Oh, it will be complaining that it's not, it's read only, but I don't care. Oh, what? expression cannot be used as a function. P++ what? Oh yeah, yeah. Texts. All right. It is Rick. Okay. Yeah. So it is Rick, but you can't recognize him right now. So let's do static int f frame count f. Yeah, that might not be the fastest method, but it's too damn fast. No, it's too fast. We need gamma. We need gamma correction. This is already Rick Astley. Rick Astley. Okay, I need to convert more images. Yeah, that's what I wanted. I want for the video something like now we need to wait for everything to convert. I want for my video like flickering, and then I don't spoil it. I don't spoil it. 300 kilobytes of image data. Oh shit, it's 501 frames. No, I want only 500 frames. Why did I get to 501 frames? Okay, let's remove the last one. Let's add this. And go to Rick. Okay, let's do it again. Is it going too fast? Is it me or is it going too fast? Okay. Let's make it 10 times slower and see what happens. It's still too fast. Yeah, let's do that. I will convert it. So we need something more like 600, and then we will do the gamma correction, okay? 2.8. Oh, I can see. Oh, you have now like, because it's I run it slower, you can see now some effects. Shit. You know what? I do that. I just display increase come on. Huh? I will just increase the frame counters more slowly. Okay. No, that's gamma. That's only gamma that you're worried about. Yeah, let's add the gamma correction. So, gamma correction. Two point two. All right, so we need okay, so yeah, first of all I do the gamma correction before anything, and also that code here, pragma once, then we need to add this, then any good there? The one in the okay. Yeah, I think the regular one is all right. Oh shit. Okay. Yeah, R0. So that's the gamma correction. I just want it to be. We need also to floor it. Oh. G and B. So let's do const gamma 2.2. So basically, 255. Oh. Yeah, it's out of your view here. Okay. So divided by 255. Why is it even? Okay, yeah, so we can gamma. That's that times that, but we need to math floor. Floor rounds. Oh. Okay. So actually I copy that again because that's easier. Boop. So it's not performant, but because it does that every single bit again and again, so it's actually doing the gamma calculations as 8 times, but I don't care. If it works, it works. Some fresh air really helped. Pop. We're almost there, my peeps. Three and 500. Here we go. That should be perfectly fine. All right. Are you ready, people? For oh wow, I mean it's 8 by 8, so don't expect too much. You can recognize it a little bit. Oh, no. You can't expect too much. Sound now. It's we have only 11 minutes left of the stream. Or I just need to. Oh, wait. How how much out of focus? Oh wait, that's with such a high. Here now you can now you can recognize it. All right, here we go. Oops. You can even see the foot. There he is. Ah. That's actually that autofocus is quite good. Nice. Okay, and I have even a recording for my video. Cool. That's really cool. This autofocus effect, and this is f of here. You if we do okay now you can recognize it anymore. Ah. What did I do? Okay. Yeah, the best is like this. Never gonna give you up, never let you down. I have no clue where the speaker is. I mean, I could do it, something there. Let me check. It's already a success, I would say. And you know what? Hertz. Each frame of the video is displayed 64 times. So 64 by I think that's 30 frames per second. The video, so it's basically 2 kilohertz. Update rate. Oh, nice. That's so cool. Oh. Oh, what happened here? Did I went offline? What? Oh no, streaming elements just said... Was I disconnected? It seems so. Might have died, my stream. Oh wait, maybe in the background something is running now. Rickroll isn't running there. Oh, so that was a reconnect. Yeah, with the gamma it looks better now. We could do like 10-bit, but then... Oh. I could do 10 bits, basically. So we get a nicer gamma correction there, but... Oh no, okay. Yeah. We can, okay, last thing that's last thing that I do today. We can try to get some sound out of it. Like just getting some sound. I don't know, I just assembled this, so I have no clue. There is an op amp. What is this? This is the microphone. Interesting. This is my MEMS microphone setup. I can't even remember that I did this. And there is the PA15. PA15 is the buzzer. Okay, let's do PA15 then. PA15, so let's get this ports GPIO here, main, GPIOA, what's A? A. Was it 15? Yes, 15. In its structure, and then I just need to do some sort of, what do? We get like a frame rate. Do we have we don't have access to that. Shoot, okay, yeah. I will just flip it like here. Wait. Oh. $15. And then we would need like a delay here. How do we do that? How do we do that? We don't have delays, so far at least. I don't know what to do. How do we delay? What does our... Oh, yeah, actually we can do... Yeah, we can use the counter basically here. CNT, where is it? Sys CNT. And then, because that's like 16 megahertz, so we can do Systic CNT, that's running at 16 megahertz. So if we shift it by and 1, (16 kilohertz) would be by 10. So by 14, 15. Okay, let's shift by 15. Oh, it's reset all the time. Shit. It only counts to... Oh no. The counter it's never counting that way, that much up. Okay, I need a subframe. Yeah. Now I'm slowing down everything. I hate it. Because that's not good anymore. Subframe. And we have 4... No, how many? 16 by... we have 500 kilohertz. So we need like 17 or 18 here. I believe. No, wait. Stop it. Kilohertz. No, that would be just 1 second. So yeah, I just do 10 and let's see what happens. Never used that audio. Oh yeah, we have audio. Nice. Okay, look at that. You can hear it. Yeah. It's working. It has buttons. Why does... I have a MIDI player. We made it for this one here. Okay, nice. Dudes and dudesks. We are done for today. I will turn that off because it's annoying. It has a MEMS microphone, so we could record and play back. That could be... That might be interesting. If we use the button to record and then play it back. Okay, we stop for today. I don't know if I can promise another stream this week, but I'm really curious if we can just make it record with the MEMS microphone and then play back. All right, peeps, it was amazing. I'm really happy. It started slow with my OCD repair and with my OCD trying to get like the lowest significant bit perfect times. Wait. Oh yeah, that's unfortunately that's... Wait, we can do this way and then we can do 4 and then we can... Yeah, here we go. This is the setting I wanted. Good night, Rota. Good night, Dutch. Good night, Secret Engineer, Sonic, Z80. Good night, Max, and every lurker out there. Here is the exciting result for today. Nice. I'm happy. Bye bye.